Welcome back. Today we're going to be talking about evaluating exponential functions. So let's go ahead and take a look at a few examples. So here we're going to be using the graph to evaluate the function. G of x is equal to 3 raised to the x power. So we're going to start with our first one where it says find g to the 0. And we can see that the 0 is inside the parentheses. So that lets us know that we're going to be looking for the input or the x value. So looking at my graph for the input of x, I'm going to go up until it hits my curve, which it does there at 1. So I know whenever g is of 0, that it's going to be equal to 1. Or I can write that as the point 0, 1. Now if I'm looking for find g of 1, again, I'm going to go over to my graph, over to the 1, and I'm going to go up until I hit my curve, and I'm going to do that at 3. So then I know g of 1 is going to be equal to 3, and I can write that as the point 1, 3. Now for my last example there, it's a little bit different because I've got g of x is equal to 1, and that 1 is actually on the outside of the parentheses this time, so I know that I have the output, and my output value is going to be y. So I'm going to go over this time until I hit my point on my curve, which I can see here where I already had the point from the first one. So I know that that's going to be whenever g is 0 again, it's going to be equal to 1 because that is where my point is, and I can write that as the point 0, 1. Now let's move on to the next example. Here in these examples, we're going to evaluate the exponential functions by using substitution. We're going to substitute the number in the expression using parentheses and solve for the unknown variable. So first, we want to remember that whenever we're dealing with exponential functions, that our equation for that is always going to be y equals a times the base raised to the x power plus k, which we know is our constant or our asymptote. So now we're going to substitute in like we've done previously when we've done linear functions. So in this case, I've got x is equal to 2. So I'm going to substitute in for x. So I've got y equals negative 3 raised to the x power, which I know now is 2, plus 4. So now I'm going to use the order of operations, but I have to be very careful because remember a is there, even though I can't see it, I see just a negative sign. So since I see just a negative sign, I should recognize that that means that a in this particular case is going to be negative 1. So I'm going to make sure that I put a negative 1 in there so I don't forget about it when I follow my order of operations, when I do my exponent first and then multiply afterwards. So I'm going to start with my exponent because we're going to follow order of operations. So 3 squared is going to be 9. So I'm going to end up with 1, y equals negative 1 times positive 9 plus 4. Now I'm going to do multiplication because that comes next. Negative 1 times 9 is going to be negative 9. Negative 9 plus 4 is going to equal 5. So I know in this particular case, negative 5. So I know the answer for y here is going to be negative 5. Now looking at the second one there, I've got y is equal to 2x plus 6 if x is equal to 7. So again, I'm going to substitute in using the things that I know about substitution. So I've got y is equal to 2 raised to the 7th power plus 6. And again, I'm going to follow my order of operations, but good news for me, in this case, a is just going to be regular positive 1. So I don't have to worry about anything with that this time around. So I'm going to just start by doing 2 to the 7th power. And 2 to the 7th power, as we all know, is 128. So we've got y is equal to 128 plus 6. And then 128 plus 6 is going to be 134. So I know in this case, my answer will be 134. So now heading to the last one, we got a little more work to do this time because we've got to figure out what k is. Now luckily for us, they've told us what both x and y are, so we're going to be substituting those both in. So I'm going to be substituting in 5 on one side. It's going to be equal to negative 4 raised to the x power, which we know in this case is going to be 2. And then we're going to have plus k because we don't know what k is on this side. So now we're going to go ahead and start by following our order of operations. We can see that we're probably going to be solving an equation. We're definitely going to be solving an equation. So remember, we've got that a in front there. We can't see it, but we know that it's there. So I'm going to put in a negative 1 just so that we don't forget it. So we're going to do 4 to the squared power. So 4 times 4 is going to be 16. So bring down everything that we've done. We've got 5 times negative 1 times positive 16 plus k. Our next step is going to be able to do our multiplication there. So we've got negative 1 times positive 16. That's going to give us negative 16. Ran out of room, so we're going to move over here. We've got 5 is equal to negative 16 now plus k. And our last step is going to be to add 16 to both sides of our equation. When we do that, these are going to cancel, leaving us with just k on this side. And 5 plus 16 is going to be positive 21, so k is going to be equal to 21. Now let's take a look at some practical problems. So here we're going to take a look at understanding practical problems. A rumor spreads exponentially through the school. If 10 people know the rumor at 8 a.m. and the number of people who know the rumor triples every hour, how many people will know about the rumor by noon? We can use the function f of x is equal to 10 times 3 raised to the x power. So x in this case is going to represent the time in hours. So what does the 10 represent? Well, 10 represents the initial number of people that know about the rumors. And this is true about any of our practical problems involving exponential functions, is that initial value, that a value that we always see, is going to be the initial amount or the starting amount. In this case, it's 10 because 10 people knew about the rumor. The next one says, what does f of 4 represent? Well, if we were to input 4, we would do that in this particular scenario because we're talking about x. So the 4 in this particular case would be the number of hours that have passed, because we want to know from 8 to noon, and from 8 to noon is 4 hours. So what does that 3 represent? Well, the 3 represents the number amounts of things that we're tripling here, right? So it said triples every hour, and since we know that it's tripling, that's the same as 3, so that's where that 3 comes from. Now let's try some practical problems on our own. So here we've got 2 word problems to do. The first one says Kesha deposits $1,000 into a savings account, earning 6% interest each year. It's probably important information. She makes no further deposits in the account. What is the balance after 5 years? Use the equation y equals 1,000 times 1.06 to the x power, where y is the total money in her account and x is the number of years. So good news is they gave us the equation to start with, and they want us to find the number of years. And they told us the number of years is 5. So we're going to substitute that in for x because they said x is the number of years. So when we do that, we're going to have y equals 1,000 times 1.06, and then we're going to raise it to the 5th power because that's our number of years. Now, when doing these types of problems, I'm highly going to recommend that you use your Desmos calculator. Rarely does finding interest like this come out to an even number, so we're going to end up with a number that we're going to have to round. So in this case, y is approximate because it's going to be approximately $1,338.22558. So that's a great number, but that doesn't really work for our system of money where we only have 2 decimal points to go for. So we're going to look for our place, find our place, look next door, 5 or greater, add 1 more. We are going to do that. So we're going to end up with about y is going to be equal to $1,338.26. Now let's take a look at the second one there. So it says Morgan just bought a new car for $24,000. However, the car typically depreciates in value. That means it's going to become less valuable over time because it's less new. It's going to value about 16% each year. What is the approximate value of Morgan's car in 5 years? Use the equation y equals 24,000 times 0.84 raised to the x power, where y is the value of the car after x years. So again, we're going to substitute in, and again, I'm going to recommend that you use your calculator. So we've got y is equal to 24,000 times 0.84 raised to the x power, and we know that it's going to be years. In this case, again, is going to be 5. So we're going to type that into our Desmos calculator, and we get y is going to be equal to $10,037 and 0.8662. And again, we're going to do some rounding there. We're going to make that a little cleaner, actually. We're going to erase some of that 37 there so we can make this look a little bit nicer. So we're going to go with $10,037.08 maybe. No, we're going to be rounding here, so we're going to be rounding this up. And when we do that, we end up with y is going to be equal to $10,037.09. Again, these things don't work out evenly every time, so you're going to be doing some rounding. But we can see the car started at $24,000, and after 5 years, it's only worth $10,037, so you can see that depreciation hits hard. That brings us to the end of this problem. It also brings us to the end of the set of notes. If you like this video, go and throw us a thumbs up. If you love this video, go and throw us a sub, and we will catch you in the next one.